Hello friends, welcome to the chapter of digital circuits. So today we are going to discuss about the digital circuits, logic circuits basically, that how we can develop a logic using the different diodes, transistors and other elements of the electronics. So basically in this video we are going to discuss about the basic logic gates and how a logic can be developed. Actually where it is useful, that is the main important question. That is the digital circuits are nowadays used in television, communication systems, radar, navigation and guidance systems, industrial process control, consumer electronics, many other electronics devices which we are using up till the date. So digital circuits are more probably are affecting our lives one and another way. So today from the digital circuits we are going to learn about the logic, how a logic can be developed. So for the logic circuits we know that the symbols mostly used, as you have seen in the previous slide, there are different logic gate symbols, but actually what happens inside the logic circuits is that the diode or transistor will play a crucial role for the particular performance of this logic and different logic functions. So logic gates are the fundamental building blocks of digital systems, but in this video we are going to learn the different logic gates by using the diode. How can a basic logic gates can be formed using a diode? We can see that in this video. So the name logic gate is derived from the ability of such devices to make decisions, in the sense that it produces one output level when some combinations of input levels are present. Here we talk about the digital circuit. So in digital there are only two values, that are 0 and 1. So we know that either we provide 0, either we provide 1, and for the understanding, for the better understanding, we can take it in a way like that 0 represents the 0 volts and 1 represents the 5 volts. So that means 1 is high and second is low. So in the logic circuits there are few levels defined, that are input levels or output levels. They are high, low, true, false, on, off, or we can say 1, 0. So these are the two levels which are generally taken into the account whenever we discuss about the digital circuits. One more important thing is that how a digital circuit can perform, that can be understood by the truth table. Truth table plays a very crucial role about the digital circuits, and from the truth table we can get the idea that what kind of logic is being taken place into the digital circuits. So in digital circuits we have a truth table, and that truth table can be discussed like this, that a table which lists all the possible combinations of input variable and the corresponding outputs is called a truth table. It shows how the logic circuit's output responds to various combinations of logic levels at the inputs. Here you can see a particular circuit in which there are two switches placed over here, and for the different combinations of the switches we can get the different output for the bulb. Here the bulb is shown over here. So this bulb will glow or not glow, that will dependent on this switches. Any one of the switch must be in the on condition so that the bulb can be glow. And so that we can say that this is a particular uh, truth table for this circuit which is shown over here. So this circuit performs different logic levels that can be defined by this switches combinations, and this combination will make a truth table according to its output by either the bulb is glowing or not. So this is the basic thing. Now we can talk about the logic. What do we exactly mean by the logic? So the basic of logic must be in the 1 or 0 condition that we know very well. Level logic may be positive or negative. Now what this thing is explained over here is that positive logic is the one which the higher of the two voltage levels represents the logic 1, and the lower of the two voltage levels represents the logic 0. That means if you are providing higher level to the, and it's also in the analysis thing that if you are taking the 0 as high and 1 as 0, then the logic will be negative, and if you are taking in the 1 as plus 5 volt and 0 as 0 volt, then it could be a positive logic. Here we can see this thing, and this is the basic funda about the positive logic or negative logic. So this is the basics of the logics. Now further we are going to discuss about the logic gates. Now there are many different types of logic gates, but they are mainly classified like this, that logic circuits can be classified in 3 different sections, that are basic gates, universal gates and special purpose gates. As we can see that basic logic gates are only 3. They are AND, OR and NOT gates. Now universal gates are NAND and NOR gates, and the special purpose gates are XOR or XNOR. So from this we can understand that the classification of logic circuits can be classified in this way, and in this video we are going to discuss only about the basic gates. So basic gates that are AND, OR and NOT gate, and we also discuss about the realization of this 3 basic logic gates in this video. So starting from the very first logic gate, that is AND gate. So AND gate has 2 or more inputs but only one output, and output assumes the logic 1 state when both inputs are at logic 1 state. The output assumes the logic 0 state even if one of its inputs is at logic 0 state. So that can be understood by further operation of this logic gate. We can operate this logic gate in this way, that if we provide 0 0 to the input of this AND gate, it will provide you the 0. Now right now you are not going to understand this thing, but whenever we are going to realize this logic gate with the use of the diode, then after you can be clearly understand that how it is possible. So first truth table, we can say that the 0 0 input gives the 0 output. If we further change the input and take the 0 1, then it will provide you 0. Further we can take 1 0, then it will also provide 0. But if we take both the outputs as 1, then it will provide you the output as 1. Now for the realization of this AND gate, we are going to discuss this AND gate using the diode. And with the diodes we are forming the circuit of the AND gate. So here is the AND gate circuit by using the diodes. This is the basic circuit that can be represented as an AND gate. Here we have two inputs, two diodes are connected, but what kind of biasing will be over here, that can be completely dependent on what, that whatever input which will be provided at the input side. And this is the plus 5 volt here, output will be taken over here. So starting from the very first case of the AND gate, mind one thing, that in this realization we are taking the 0 as 0 volt and 1 as plus 5 volt. So basically from the very first case of the AND gate, we are going to understand the AND gate, that we are providing now AND gate using the two different diodes, and we are providing 0 voltage levels, means the switch is earthed right now. So the switch is earthed, and you can see that both the 0 are provided over here and the output is 0 for this case. Why it is done? Because the diode is now in the reverse bias condition. Pardon me, in the forward bias condition. So here we can say that the diode will be in the forward bias condition, but no output will be there as the current flow in the reverse direction. You can see this thing by this arrows. So after this we are taking the second case, when the D2 diode will be provided the 5 volts, that means the B is equals to 1 and A is equals to 0, and hence the output will be 0, because you know that both the circuits are now here it is open circuited, and this circuit will flow the current in the reverse direction according to the output. If we want output, then current should be directed like this. So here we can say that the no output current will be there, or no output voltage will be there. So by taking the third case, we can see that A is equals to 1 we are providing and B is equals to 0 we are providing. But here we can see that the D1 is open, that means reverse bias condition, and D2 is in the forward bias condition, but the current flowing is like this and no output will be there, so the output will be your 0. Now taking the fourth case, in both the case we are seeing that both the voltage levels are provided the 5 volts, that means 1 logic is applied, and hence the output will be 1 as because the current will flow in this direction only, as the arrow shows you that this will be the current direction and the output will be 1. So basically from this logic gates we can understand that how a real AND gate will work by using the diodes. This can be also possible using the transistors, but for transistors there will be a different video, and in that video you can able to understand the how transistor will realize this gates. So after this, if we want to increase the number of inputs, then it can be possible in this condition that if you want to make a 3 input logic gate, then it can be also possible, and the 3 input logic gate can be represented like this, and it will be simplified in this way that you are providing 2 inputs over here and 1 input will be separately provided at the output of this first AND gate, and whatever the output will taken will be y is equals to a dot b dot c. Here we know that the dot operator represents the AND gate, and this will be the circuit symbol for the 3 input logic gate, 3 input AND gate logic gate. So this is the basic working of the 3 input AND gate, and here we can get the truth table of the logic gate. So going forward to the OR gate, that how an OR gate can be represented, that we know that this is the basic circuit symbol of the OR gate. OR gate has 2 or more inputs but only one output, same as the AND gate. Output assumes the logic 1 state when even if one of its inputs is in logic 1 state. Output assumes the logic 0 state only when both the inputs are in logic 0 state. So this is the basic function of the OR gate, and plus sign will represent the OR operator. So mind well and mind these things in your mind, that this different logic gates are represented by the different operators. Here we can see that the OR gate, now we are taking the operation of this OR gate and how it can be realized. That OR gate is first we have provided the 0 0 input and the output will be 0. Now onwards we are changing the output 0 1 and it will be providing the 1. Once again 1 0 will be the 1, and both the inputs are 1, then it will be represented as 1 at the output terminal. How this can be possible, we are seeing in the next circuit, that is realization of OR gate using diodes. So in this condition you can see that the diode position is in reverse compared to the AND gate. So first case, we are taking the A is equals to 0, B is equals to 0, it will provide you the 0 output. As you can see, both the inputs are in open, means to say that both the switches are in open circuit condition, hence the current will flow like this, and no output will be there. Further we apply the 0 and 1 input, then we can see that the output will be 1. Here we can see that any one of the switch will be operated and the output will be provided. So in this condition your output will be 1. For 1 and 0 your output will be 1. And further for both the diodes we are providing the high, that means 1 1, then it will also represent the output as 1. Here we can clearly understand that diode can be operated by providing more than 0.7 or 0.2 volts by understanding the concept of diode, that minimum voltage level to turn on the diode. For the silicon diode it is 0.7 volt, and for germanium diode it is 0.2 volt, 0.2 to 0.3 volts are required. So here we can understand that this realization of OR gate using the diodes. Further we can increase the inputs using the different logic by providing the same logic which we have used in the AND gate, and it can be represented as this. This is the 3 input OR gate. Here we are taking the 2 input at first OR gate, and after that the output will be provided with the third input at the second OR gate, and the Boolean equation, that is y is equals to a plus b plus c, this plus operator will represent the OR operation, and this is the basic circuit symbol of the 3 input OR gate, and this is the particular truth table for the 3 input OR gate. Now further, the last but not the least, that is NOT gate, and it is also very popular as an inverter. So we are going to discuss now the NOT gate. NOT gate, also called inverter, has only one input and of course only one output. It is a device whose output is always the complement of its input, that is the output of a NOT gate assumes the logic 1 state when its input is in logic 0 state and vice versa. Here I want to say that the NOT gate cannot be realized by using the diode. So NOT gate realization will be understood in the transistor operation video. So we can understand basic operation of the NOT gate by preparing a good truth table, and we can able to understand by providing different logic gates. As we provide the 0, then it will be 1, and if we provide 1, then it will be 0. So this is the basic realization of NOT gate. For further realization how it can be possible, you need to see the transistor video. So transistor are also be used instead of diodes, and it can also form logic circuits. So this is the basic logic gates, and for NAND gates and NOR gates, that are universal gates, there will be explanatory video. So after that you can able to learn from that video. Soon I am going to upload that video. So that's all for the basic logic gates. Thank you so much.